All right, this is the Math Models Unit 4 review video. Just going to run through a couple of examples of the regression lines, which is really the only actual kind of like math stuff on the test. Everything else is mostly vocabulary. You'll see some vocab examples, numbers 1 through 9 in the study guide. Just use the unit in your notes to answer those. Won't be going over those. I also put the links for the different regression lines here at the bottom of the first page. And then after that, the rest of this is mostly doing the regression with one exception. There's one other type of question. So I'm going to jump over to the Google Keep, and we're going to go over these questions one by one. So enter the data from the table into your calculator, and then it asks you to find the scatter plot or the model, the equation of the line of best fit, and then use that to predict. So we're going to talk real briefly about how you tell the different lines apart. So if you have a linear regression, you will notice that the y values are either increasing or decreasing at a constant or almost constant rate. So it's going to just go down or it's going to just go up, and that is going to show you that it is linear. So it's going to be decreasing or increasing at a consistent rate. For quadratics, you're going to be looking for y values that either go up and then go down, or go down and then go back up, one or the other. And then cubic is going to be one where there's sort of like a zigzag. There's up, then down, then up again, or down, up, down again. So you'll have kind of like it going in almost like a wave. So you just have to pay close attention to those values, and we'll go over that as we do this. So for instance, in this first one, I can see that it's 21, 19, 17.5. You can see that the y values are decreasing, and they are decreasing at a pretty constant rate. They're not going back up or doing any sort of zigzagging. It's just kind of going down. So this tells me right away that this is a linear model. So I'm going to use my linear function graph. So I'm going to open that Desmos graph. You can have those links handy when you sit down for the test. And I'm going to enter in these values. 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6. We get through, and we have 21, 19, 17.5, 17, 16.5, 15, oops, and lastly 13.5. So I can see that these lines, there is a decrease. I see the green points, those are the points of the line, and or the points of the scatter plot, and then the orange line is the line of best fit. And so I'm looking at the M and the B down here as my values for my function. So I am going to go over here, and the line of best fit is going to be y equals M, which is the negative 1.125 times x, and then plus or minus whatever this is 20.4, we'll do 20.45 plus 20.45. So all I'm doing is copying those down. Remember, linear means y equals mx plus b. You can see that right here as well. And then all I have to do for the final step is use the equation to predict when x equals 7. I'm going to go down here. I'm going to type x equals 7. And then this point right here will tell me the answer. So what it's doing, it's finding where 10 or where 7 crosses my line. It crosses at 12.57. And so y equals 12.57. Now, something to note, on the test, you're not going to be coming up with these values out of nowhere. They are going to be answer choices. So when you go to especially that third part of the problem, just make sure you're picking the one that's closest to the answer you got on your example. All right, so that's an example of a linear. Let's move to the next one here. We see we have a graph, and it looks also like this is increasing. It's increasing at a pretty constant rate. There's no up or down movement on the y, so I think we have another linear model. So we're going to go back and we're going to look at our linear regression. We're We're going to go back up here to the top. We're going to get rid of the 6. We don't need it. We don't need this last line. And we have, let's see, 120, 280, 120, 280, 520, 680, 1080, and 13, was it 1320? 1320. All right, so we're going to get rid of this x equals line for now. We have our line. Obviously, these are really large numbers, so you have to zoom way out to see them. That's not really that important, though. You have your m and your b. 244.57 is our m. So y equals 244.57 x plus 55.23. And then we want to know what happens when x equals 6. Go over here, x equals 6. I'm going to zoom way out until I see that intersection point. It's going to be somewhere up here. This is a bit of a difficult one here. There it is. 1,522. 1,000, y equals 1,522. That was a little weird because the graph is zoomed out so much, but you can still always click on those lines when it's first graphed, and it will still give you the answer. So for instance, if I do this again, 6, and I click on those, it will find that line for me, and if I just scroll up enough, there it is, and that's what we found earlier. All right, so that's it for number 11. Number 12 is not a regression line. This is just using the data in this table. It says here we have some 9th graders, 10th graders. They have oranges and bananas in this monthly spending. You did a lot of these examples in the unit. How much of the people who chose bananas spend in all? So that's going to be this section of the table. And we're going to be multiplying those numbers. So 95, 9 times 25 and 7 times 41. And we're going to add those answers together. So 9 times 25 plus 7 times 41. So 9 times 25, we'll hop over here. It's 225. 7 times 41, 287. Add those up. 225 plus 287 is 512. So that would be the amount of money they spent overall. Not a lot to say there. You did a ton of examples of this in the unit, so I think you guys will be fine on that. All right, 2 more regression problems and then we're done. It says here to do the calculator. I see here that there's a graph that goes up and then down. So 10, 12.65, 13, and then it goes back down. It doesn't come back up again. So this is going to be a quadratic graph. Remember, quadratics are in this form, ax squared plus bx plus c. So we're looking for a, b, and c in our regression. So let's go open this graph here for quadratic. We'll enter our data into the table from the table. We're going to go 0, 1, 2, 3, 4, 5. Clear all this information out. 0, 1, 2, 3, 4, 5. Over here, I have 10, 12.65, 13.2, 12.55, 11.6, 11.25. Okay, so I'm going to get rid of this X line for now. We don't really need it. So I can see the points in orange are bunched up down here. I was pretty zoomed out, so let's zoom back in. Here we go. Oh, I made a mistake there. That was 10. There we go. So this is my line. You can see it goes up then down like our data points did. So we have our A, B, and C values. So we're looking at these values. We have our A, B, and C values. So we could take those and make that into our formula. So it's y equals, and then it's going to be the A value, which is negative 0.375 x squared. 1.945 is our B, so plus 1.945 B, or X rather, and then plus 10.45. And then we want to find out when X equals 6. So we go down here, we type an equation for X equals 6, and we see that the graph is at 8.62 when X equals 6. That's pretty much it. All right. I'm guessing our last one's going to be cubic. Maybe not, though. Actually, this one looks like it is also quadratic. So we have 1, 5, 8, 10, 8, and 5. You can see it's pretty symmetrical. It's going up, then back down. So we're pretty sure that's quad. I don't think there's a cubic on the test, so hopefully that will be less for you to worry about. 1, 5, 8, 1, 5, 8, 10, 8, and 5. So we have these values here. We have our graph. The graph is as an A, B, and C value, negative 0.98 x squared plus 5.7 or 5.8 x plus 0.68. And then we want to know where X equals 6, which is already on here, which is nice. And it actually equals 0.1. So you can see that's the process. We went over a ton of those in the lesson, so just make sure you're kind of up on that. But that is it for this review. The vast majority of the test is vocabulary plus those regression questions, and that's pretty much it. So please reach out to me if you have questions. That is it for the Math Models Unit 4 review.